Good evening, everybody. Today, we're going to be looking at tables and finding patterns in the data. And then, once we decide what type it is, then we're going to solve that. So as I look at this first table right up here, I see 1, 4, 3, 7, 5, 10, 7, 13, 9, 16. I know you needed me to read that to you. As I look at it, I can see that the X column is increasing by 2. The Y column is increasing by 3. So when it is adding both, that reminds us much of the slope of up a certain amount over a certain amount. So we are going to look right here and know right away if it's add, then it is linear. And again, you can use AX plus B too. So add. Here we go. And I'm going to, just like I did before, pick two equations. It does not matter which ones you use. Plugging in the X and the Y. And because my variables M and B are attached by addition, I'm going to use subtraction here. And you know what? This is going to make all negatives. Oh, it came as 1. Well, we can do it. We'll practice our negatives. So 4 minus 7, negative 3. 1 minus 3, negative 2. B minus B goes to 0. Divide over the 2, and I have a slope of 3 over 2, which again I could see, here's my Y, up 3 over 2. So then just pick one of the equations. It is wonderful. You know what? Let's pick the one where it will cancel out. So 7 equals 3 over 2 times 3. Just kidding, it's not going to cancel out. It would just be nice if it did. So 9 over 2 equals 7. Subtract the 9 over 2. And there you go. You have 1.5x plus 2.5x. All right, you can see your U try right there. So it's already decided for you. This is linear. Tell me, how do you know it's linear? How much is this column adding by? How much is this column adding by? Okay, I know you've sat down and done that work. There we go. Hopefully you got the same function. So now we're going to look at the next type right here. And I can see, lovely, which is one you have? As I look at this one all the way in the corner for me here, my X column is adding by 2. And then my Y column, I can see that I am multiplying, okay? If you're going through there, you do 2.5 divided by 0.1, that's 25. If I do 62.5 divided by 2.5, that's 25. So that tells you these are multiplying by a constant. As you look at that, it's going to move steady along the X, big jumps as I'm going up the Y. That lets me know I've got exponential. Okay, so as I start, Y equals AB to the X. This is add, multiply is the pattern. And again, pick 2 points. It does not matter which one. So 2.5 equals AB to the first. I always like things that are easy. And then I'm going to go 62.5 equals AB to the third. Change here. Now we're looking, my A and B are multiplied together. So the opposite of multiply is divide. So first, 62.5 divided by, I think we just did this, by 2.5. Yep, there's my 25. A divided by A will cancel. When I divide the bases of B, I subtract the exponents. Take the square root, and B equals 5. Next, you're going to go through, plug that back in. So I'll just write it right here. 2.5 equals A times 5 to the first. So 2.5 divided by 5 is 0.5. And if we're lucky, there we go. That one worked out for us. Okay, the one I would like you to do is this one right up here. Please try that right now. And there's the answer you should come up with. All right, looking at the next one here, I can see this side moving up, definitely moving up. I can say, all right, 3 to 6 multiplied by 2, 6 to 12 multiplied by 2, 12 to 15 is not a multiply by 2. That does not mean that there isn't some kind of multiplying pattern. There are terms we're obviously skipping in here, but if you can find the pattern for 2 sets, so I have 3 to 6 multiplied by 2, 6 to 12 multiplied by 2. So now let's see what that column over here is doing in the y's. So I have 1080 divided by 135, because it's definitely not something with addition here, and I get 8. 8640 divided by 1080, and I get 8 again. So again, that bottom term is still going to be in the pattern, because okay, the next we would have to have 7.5 to see the pattern there. So if it's a multiply, then that's a power function. So ax to the b. So same process we've been doing here. Pick 2 points, plug them in for x and y. 3. Because the b is an exponent, but because the a is multiplied to that term right there where the b is attached to, we're going to go through and say, let's do division. So I get 8 right here. A's cancel. I'm going to divide this. 6 divided by 3 is 2, and they were both raised to the b. I now have an exponential right here where my variable is the problem, so I'm going to change that to logarithmic. Base of 2 of 8 equals b. And I end up with b is 3. Take just a second now. Let me get us some more space. Plug that back in. So I'm going to have 27a equals 135. And that is 5. And that matches even better. And then you're going to try the one that's right next to it, right over here, the 13927. You're going to do great work right now. And that's the answer you should come up with. The last type we're going to look at here is you're going to go through some of them. And again, based on what data you have, you're going to try add. You're going to try add multiply. You're going to try multiply, and nothing will work. It'll be horrible. So you're going to try this next one. And you're going to look at them, and you're going to subtract them. And you're going to say, okay, 34 minus 4, 30. 80 minus 34, 46, 62, 78. Well, that's nothing. That's absolutely nothing. We knew that because add didn't work. It wasn't linear. So now I'm going to try that again. And I'm going to subtract those out. And now when the second difference does work, you just do the happy dance, because that means it's a second power function. First difference is a linear. Second power is the function. So go ahead. You're going to pick 3 of the points. Use an awesome time, and there's your answer when you finish. Remember to pick 3 variables, go through them, and enjoy. I'll see you tomorrow.